So across just 50 functional genes, the odds of you sharing the same exact code as a non-relative, believe it or not, is 1 in 14.5 quintillion. I know it's astronomical, but when you start thinking about all the genes and all the things that can just be minutely tweaked, then it becomes kind of, well, yeah, you can kind of believe that. So when you think about all those differences and that no one is the same, the odds of you also finding the exact right longevity protocol, well, it might take a little bit of time and take a little bit of tweaking. And so what I invite you to consider today is pairing genomic testing with your peptide longevity plan to make sure that you understand what is compatible with your biology and maybe what is not. So thanks again for joining today. So think about this. Your genome is the one input that doesn't change at all. It never changes throughout your entire lifetime. But your labs, they change. They can change daily. They can change in the middle of the day, depending on what it is that you're looking at. Your wearables, they give you different data every single night. Your supplements and even peptides, right? They get rotated as you start to, do better, focus on something else, some other part of your health, right? So these are kind of things that are always changing, but your genetics, your DNA, they don't change. However, what we can do is help to your body to express either more or less depending on the support that you provide it. And if you provide the correct support to make sure that your baseline biology is working great, that is really what helps things like peptides, supplements work even better. So before we get into the talk very specifically about peptides, let me take a moment just for the novices that may be on this call here. What is the difference between your genome or genes and genomics and SNPs? So your genome is all of your DNA, like all of it, all 3 billion base pairs. And what's crazy, even though I gave you that amazing statistic up front about the odds of you being identical are 1 in 14.5 quintillion, actually 99% of your DNA is identical between two people. So we're just talking about that 1%. I know, crazy, right? So when we take a look at the genes in and of itself, 99% the same. So we're talking about that 1%. And when we look at genomics, what we're talking about is looking at the differences between multiple genes. So we're stacking genes. We're not just looking at one gene at a time. We're looking at the multiple effects of things, like I said, over time. So think about it like this. It's kind of like in your workplace. If you worked in a big company and you have a department of individual contributors, right? Each person in the department, that's like each person is a gene. So when we look at genomics, it's kind of like we're looking at the output of the whole department. And then SNPs are the single letter differences, those little differences, at specific spots on each of these genes. So the one little thing that each person does a little differently, right? Their strengths and weaknesses. And then we take all the strengths and weaknesses of everybody and we look at all those little SNPs together. So in plain English, a SNP is a single nucleotide polymorphism. You don't have to remember that. Let's just use SNPs because that's easier and more fun to say, frankly. And how many SNPs actually matter in the grand scheme of functional medicine? Well, there are hundreds and hundreds of thousands of SNPs that had been identified. And when we talk about, longevity studies, we typically kind of look at around like 50 to 100 at a time. We can look at a lot more if you have very specific things that might be unique to your body specifically. But in the grand scheme of things, we start out at about 50 to 100. So there's about 4 conversations that we typically include when we're talking about longevity, and that is lifespan and resilience, methylation and detox, huge. Most people have never even heard of methylation, so important. Oxidative stress. And that leads us right into growth hormones and repair signaling. So everything that I'm going to talk about for the rest of the time really drops into one of these 4 buckets. And like I said, why these 4 and not others? Well, because they have the strongest evidence that you can actually act on. So everything that we're talking about today is all about being functional, like you can actually do something about it. That's why you're here, right? Because you want to do something about your health. Now, would one genomic test cover all 4? Absolutely. Yes, a really good longevity panel reads all 4 of these major categories and so much more in a single sample. All right, so we're going to talk about 3 different people today. We're going to talk about Marcus, who's 46, and he wants to lose weight and he wants to age well. And so he has that question that's on a lot of everyone's minds right now, which is, are GLP-1s right for me? Then we have Diane, who is 54. She says she feels and looks older than her age, right? And so for her, we're really going to take a look at the mitochondrial and collagen genes. And then we have Sam. Sam is 37, and he has failed 3 antidepressants so far, right? So we really have to take a look at him with around his methylation and plasticity stories. So are these real patients? They are built on composites of real patients that I have worked with. And the other question is, you might be having this question, what if I'm a mix of all 3? And you know what? Most people are. So you're in good company. And the point really is the methodology that we're going to talk about today, which works for any of these combination of symptoms. So, like I said, Marcus, he wants the shot that everyone is on right now. He, like I said, is 46, carrying about 30 pounds that he can't shift, and he is watching other people melt this fat away on semaglutide, right? So he's not just chasing a number. He has read the longevity research. He's taken a pause. He really wants to understand this. And what he realizes is that he wants a shift in his real metabolic health. He just doesn't want a quick fix that's going to stop working once he goes off a GLP-1, but what is going to set him up for true longevity, right? So what is the one that his biology, that will cooperate with his biology? So really, when we take a look at Marcus's genome, what we see is that his appetite, which he self-confessed is pretty high, it's not a character flaw. In fact, the hunger and fullness signals that he's getting are very much hardwired into his genome. There's 3 specific genes that we will take a look at that shape how well a GLP-1 will work and how much work there is going to be needed to support the GLP-1. And a very, very important family history question that we have to ask first, right? So you might be wondering with Marcus that, and many other people who are considering this, isn't wanting a GLP-1 the easy way out? And the answer to that is a definitive no, because for some people, they are biologically wired to have an enormous appetite. It's just how they are. And these drugs were literally created for these people, right? And maybe you're thinking, well, can he just diet harder? And it's not about the dieting here. It's about the fullness signal coming from his brain to his gut. It is genetically muted, like just like you're all muted now, or most of you are, on this webinar. It's muted. So willpower diets will fail for these people. Absolutely. So let's talk about those genes. When we talk about appetite being wired and not weak, we're talking about the FTO, the fat mass and obesity gene. And for him, the AA version, which he has, it turns up hunger and BMI starting from childhood. And you all know that, if you start down that road in childhood, it is very hard to turn around as an adult. Then we look at the MC4R gene, the snacky gene, as I like to call it. So Marcus is a CC for this particular SNP on the MC4R gene, again, which is the brain's fullness switch. And this mutes that I'm full signal like we were talking about. So again, this is a perfect use of GLP-1s. But then we take a look at the appetite hormone genes. And this is typically, we're talking about insulin and insulin resistance and how their specific body responds to food. And, basically it's the insulin sensitivity. So they set how strongly then he's going to react to a GLP-1 as well. And, we also talk about the glucagon arm in retatrutide, because that's a new part of this. That's the GCGR gene that we just started looking at, because now we're evolving these GLP-1s to hit several different receptors in the brain. And so let's talk about that right now. So like I said, retatrutide is one GLP that potentially could work for Marcus. It is, like I said, it hits 3 different receptors. So the GLP-1 receptor that we all talk about all the time, then the GIP receptor, again, which is very specific to insulin, and then the glucagon receptor. And what we see is about a 28% loss in phase 3 trials with this, which is the strongest yet. It's why everybody's looking at this GLP-1, why everybody wants to be on it. So then we have the tirzepatide and the semaglutide, which have been on the market. Tirzepatide is the dual GLP-1 GIP as well. And then we have semaglutide, which is straight GLP-1. Right. So we see this evolution of peptides coming along. And there are caveats for each of these. So for example, overall, before we even start, we have to ask the question, do you carry a RET gene mutation? Because if you do, that's responsible for what we call a MEN2, which is a unfortunate mutation that makes you much, much more susceptible to a type of thyroid cancer. It is rare, but what I have learned in my genomics journey is that every time I tell somebody it's, rare, 1 to 2% of the population, that literally shows up in their panel. So I've learned that when you're talking about, hundreds of millions of people, 1 to 2% is a lot of people, and and these things still show up. So it's very important to kind of take a look at that. It's a very easy test, by the way. Now, I'm just going to call it Reta because that's a mouthful. So like I said, Reta is the newer one. It has the extra glucagon action, but this in some people does cause skin tingling, which we call dysesthesia, or pins and needles. Tirzepatide can bring on nausea in some people. So that's why if you're working with a practitioner, definitely start at a low dose and work your way up, just because, you know, we don't know who's going to experience these side effects or not. You may not at all, and that's great. Good to know about in advance, however. What to track? Now, in the beginning, I talked about how we are all individual. So what we need to be tracking is not how we're doing versus other people that we know that are on GLPs, but how we're doing against our own baselines. So tracking our weight, obviously, but our waistlines, our fasting glucose numbers, and above all, like how steady your appetite feels. You know, because this is, like I said, highly individual. So we need to make sure that we're not comparing ourselves to anybody but our own baselines. Now let's talk about Diane. I said, Diane, 54, she's already feeling closer to 70. Why is that? She bruises easily. If she pulls a muscle, it's 3 months for it to heal. Her skin lost its bounce a decade ago. So she sequenced her genome and she found out that she has some issues with her mitochondrial defense genes and her collagen. And you know what? She was kind of happy about that because for once she feels like she has an explanation for what's going on. So like I said, what she's noticing, constant low energy, poor recovery, slow healing joints, tendons, skin, and her face that has aged a lot faster than her friends. So what her genome says, what we see is that she has a high oxidative load. Like, you know, there's just damage that is occurring in her cells and not getting cleared. And so the repair systems, you know, it's hard to work when there's a whole bunch of clutter and waste around. So she has mitochondria that run hot and clear damage slowly. She has collagen that remodels slowly. And like I said, a repair system that needs help, not just rest. So maybe some things you might be thinking about, because, you know, I know, you know, this is definitely, you know, sometimes true for me as well. Is feeling older than your age really genetic? Partly, yes. When we talk about genomics, we're talking about 60 to 65% of what you experience is genomics, is what you inherited. But a large part of this, about 40%, is environmental. So that's why I say partly, right? So some people genuinely make more cellular damage than other people and repair it more slowly. So can she actually change this? Can we change this? I know that's what you want to know. And we can definitely support it. We can help her improve and slow down this damage. We can't erase things entirely. Some things we can definitely clear and get rid of. But can we turn back time? Hard to tell. That's different for everyone. So let's take a look specifically at what Diane's genome says, and then we'll get into what we can help her with. So the SOD2 gene is what I like to call the smoke control gene. So Diane is a TT, and SOD2 is the mitochondria's main antioxidant. See, there's this thing happens, and I'm gonna go back to this slide in a second. There's this thing that happens in mitochondria. Now, mitochondria, as you know, the energy production center of the body, right? So your cells have hundreds, thousands, sometimes hundreds of thousands of mitochondria in every single cell, and their whole purpose is to create energy for the body. Now, as you know, when you burn fire, you make a fire in a fireplace, what are you doing? You're creating energy in the form of heat. And heat is awesome. Heat keeps us warm, it gives us light, helps us cook our food. It's wonderful. But a byproduct of fire is inevitably smoke. Smoke is not good for us. So think of smoke as kind of the reactive oxygen species that is created in mitochondria as a byproduct of energy creation. It's a necessary evil to get to the energy that we need, right? So that's why I call SOD2 the smoke control gene. So SOD2 determines how well you're cleaning up that smoke in the mitochondria. And unfortunately, Diane has the version that's not so great at cleaning up the smoke. So she needs some help with that. So then we have other genes, GPX1 and QO1. They're the cleanup crews, right? So they help to further neutralize that smoke. So what SOD2 does with reactive oxygen species is it takes it and it turns it into hydrogen peroxide. And then what other genes like GPX1 do is take that hydrogen peroxide and turn it into water and oxygen so that we can breathe it out and urinate it out, right? And then we have the COL1A1 gene, the collagen gene. And unfortunately, again, Diane has a suboptimal version of this, which means that she has slower remodeling collagen, right? So that's why she's healing so slowly. So let's take a look at what we can do for Diane. For Diane, we would take a look at MOTS-c, humanin, mitochondrial-derived peptides. These are typically the first line of things that we look at in people with a slow or poorly functioning SOD2 gene. Then we have things like SS31, which stabilizes the inner mitochondrial membrane, which supports the electron transport system. And, you know, really just what it does specifically is stabilizes cardiolipin, which actually I'm going to show you this graphic right here. So unfortunately, we have the reactive oxygen species, you know, those are those little sparks you see, but we also have the cardiolipin. And that's what makes those little cristae, those little loops in the inner membrane of the mitochondria nice and strong and able to hold that fold so that, you know, the mitochondria can support the electron transport system. So SS31 helps to support that all of those little inner cristae made up of the cardiolipin. And then we have GHKCU, BP157, and TB500 to help with the collagen deficit, right? Now keep in mind, for any of these peptides to work well, we have to support the body, the baseline. So that means that we're making sure that Diane has enough vitamin C. Everything in the skin, the extracellular matrix, all of our peptides, they're created from vitamin C. Also, glycine is also a huge building block, and as well as proline a little bit as well, which I don't have listed here. Now also keep in mind, this is all very new. Within the last probably 10 years have we really started looking at peptides as solutions, and we're getting new information more and more every single day. So while right now some of these peptides don't have a ton of literature support, they have a lot of clinical evidence, but there are tons of studies being done. And so the evidence is going to continue to accumulate. So make sure that you are keeping up with the latest and greatest news and studies. And I know that, you know, Tony here with the Longevity Plan folks, they are on top of that. Check out their blog for sure. They have tons of great info on there. Another thing to keep in mind is IGF-1. Growth hormone peptides. Yes, they aid in repair, but they also raise IGF-1. And in some people, especially those who have had a history of hormone-sensitive cancer or issues with cognitive decline, should avoid increasing IGF-1 levels. All right, Sam, our final case study for today. Sam, 37, he has spent years cycling through SSRIs. And each time they don't work and he gets labeled treatment resistant. I know you know this story, and I know that you know someone like this because we all do. So when we take a look at Sam's genome, what we find is, of course, they weren't working for him. It is right there in his genetic code. So what Sam is feeling, low mood, flat motivation, and like I said, the med's not helping. Months lost to each trial and error round, and he really is starting to feel like nothing is ever going to work for him. What do his genes suggest? That they were just the wrong fit, and that is not the only option for him. So first of all, we took a look, and his folate and his methylation systems were suboptimal. So we know he is just wired. The way his wiring is that his methylation system is not going to keep up with neurotransmitter demand. So it absolutely needs support. His dopamine and serotonin handling are tuned against standard SSRIs. They're just not going to be helpful to him, just because of his wiring, like I said. And then also low neuroplasticity signaling as well. So the genes we specifically were going to look at, and if you work with a practitioner like myself, trust me, when we methylation, we're going to spend a lot of time on that, and there's a lot more than MTHFR. There's, actually like 7 or 8 genes that are very important. But for right now, most people understand MTHFR, which is your folate processing gene. And Sam is super suboptimal here, right? So his ability to activate folate into methylfolate, which is what the body needs for any of these peptides to work, for his own neurotransmitters to work properly, he's only at about 30% efficiency. That's a huge swing from somebody who is, wired the other way at 100% efficiency. Yes, there can be a 70% gap from person to person on how well their body activates one of the key chemicals that the brain needs to process neurotransmitters. So then we look at COMT. COMT, another, arguably one of the most important genes for you to understand for your mental health and for your hormones, for your methylation detoxification. It is so important, in my mind, to truly know what you are, because that is the gene that determines how well you clear and allow the body to replenish new chemicals constantly. And it's not just neurotransmitters, it's your hormones as well. And like I said, it's involved in every major cascade in the body. And again, Sam, he is GG, which means that he clears things, unfortunately, too quickly, which means that antidepressants, they don't have time to work. They are tied to weaker responses when you clear too quickly, right? So this also changes which peptides he's likely going to tolerate as well, because he has that super fast clearance, right? Because you want your peptides to hang around as well. 5-HTT-LPR, BDNF, serotonin, and repair genes. We look at those because it determines how Sam looks at the world in the first place. He has the short serotonin transporter version, which is a very poor fit for SSRIs. And with his moderate response for BDNF, that means that he has a lower baseline brain plasticity. So both of these point to raising BDNF directly. And you may be wondering, well, Jennifer, what does that? Well, let me tell you. So first of all, we're going to make sure that he has plenty of L-methylfolate, the activated form of folate, like we talked about earlier. He's only at 30% efficiency. We want to make sure that that MTHFR bottleneck gets fixed, because we want other peptides to work well, and specifically looking at Cmax and C-Link. So Cmax I'm sorry. Yeah, Cmax is an ACTH-derived peptide that raises those BDNF levels and modulates dopamine and serotonin, right? So it's both a mood support, but it's also a nootropic. And then we have C-Link, which is an anxiolytic peptide, so for anxiety, that lifts hippocampal BDNF, which is, BDNF, by the way, is brain-derived neurotropic factor and is very important in learning and memory. We look at it for understanding your cognitive function, how quickly you make associations, but also how fast you process information. So if you process information quickly or too quickly sometimes, you're going to be more high level. But if you take longer to process information, yeah, it takes longer, but you process it more thoroughly as well. So it's just a difference in how your brain processes new information and recovers from injury. That's a huge one as well. So again, C-Link and both Cmax help support BDNF levels as well as neurotransmitter levels. So important thing to point out, these are adjunctive, right? So they're not typically used alone, especially in someone who is dealing with depression. And they need real care and monitored by a professional, right? So genomics is going to help guide this, but it does not replace treatment with a qualified healthcare professional. And then, like I said, COMT matters enormously. Know your COMT, okay? Because COMT AA, slow clearance types, you have to go really gentle on dopamine pushing support, right? But people like Sam, who was super fast, they can tolerate a lot more of that. Slow COMT people cannot. You have to start very slow with those folks. Now, another thing I want to point out is that peptides aren't the only thing that we can do for SAM. So remember, peptides are awesome to use adjunctively in a whole longevity plan, as Tony talks about a lot, right? So we're not just looking at peptides, we're looking at the whole picture here. Because if SSRIs aren't my answer, what actually is, right? So there are other things that you can use, like bupropion, which works specifically on dopamine and norepinephrine, right? Not on the serotonin transporter proteins. So Sam's short 5-HTT-LPR doesn't get, held against him, basically. He can work on other pathways. Saffron, surprising amount of great literature and clinical support with saffron, solid trials, beating placebo, and has been rivaling actual prescription antidepressants and head-to-head clinical studies. So a very reasonable natural add-on. And then again, looking at methylfolate and potentially adding some SAMe directly in there. SAMe is S-adenosylmethionine. It is the whole product of the methylation pathway. It is the universal donor of methyl groups, which allows a lot of the, chemical reactions and chemical cascades in not only the brain, but throughout the body to work properly. So just, some more things to point out. Switching drug classes sometimes beats switching brands. So that's why, maybe we look at something other than SSRIs. Plain folic acid is not going to be helpful to someone like Sam with a poor MTHFR. So he needs to use either methylfolate or something like folinic acid, depending on a couple of other genes. Because we don't want to cause anxiety, which overmethylation can cause. Just try harder is never going to work for somebody like Sam, right? So he needs real, true support of his actual biology, which the appropriate supplements and peptides can help with. So I know we're already over. Thank you for hanging on. There's a lot of things that are proven right now that I've talked about, a lot of things that are in the works being actively studied. So please make sure that you're keeping up on this if it's something that interests you. What should you actually do with all this information I gave you? Well, definitely look into genomic testing, look into understanding what peptides are definitely going to jive with your biology. Talk to myself. I'm Jennifer with the Genomics Company. You can check me out on thegenomicscompany.com and Tony at the LongevityPlan.AI as well. And thank you so much. And I'm going to turn it over to Tony for a few words or comments or questions.
Sure. One question I'm sure everybody has, but your genetic tests, do they give recommendations like this about what is, how my genes work and what may be good or not as effective for me?
Yes, absolutely. And that's one of the beauties of the genetic test that I'm actually a co-founder of. It's called Precision X Health is our lab, and I use that in my own company. So yeah, lots of companies going on. But what's the beauty of it is we not only do your genomic testing, but we make it very easy for you to see which supplements are going to be very specifically helpful to your genetic wiring. We even have tests specifically looking at peptides. So you can get an actual peptide report for you to help you decide, which ones are going to work or be compatible with your biology. So thanks for asking, Tony.
Great.